what is it like to be a developer in Kubernetes and working on it and using it? Building the applications and deploying them on Kubernetes clusters is really awesome and really cool. We all love it. But the process of developing the container applications is time-consuming, and it's difficult. It is even harder at the larger enterprises, where the security takes the front seat. Today, we'll be talking about the container developer experience versus a strict security posture. At the end of this session, you will walk away with a workflow that will help you to improve the developer productivity using the open source tools. Let's get into that. My name is Sharat Nellutla. I'm an associate director at Verizon. I lead Kubernetes platform engineering teams. I've been using the Kubernetes for like last 5 years from the version 1 that we released in July or 2015, around the time. I'm presenting with Brian today.
Hi, I'm Brian Bagdzinski. I'm also on the Kubernetes platform team at Verizon. I specifically focus on the developer experience and the tooling. Prior to that, I helped stand up the serverless platform at Verizon and did app development for several years. I'm pretty sure I'm the only person with that last name in this world. So if you search me, you'll find me and my family if you need to know more.
All right, let's quickly see who we are. We are Verizon US, the most reliable wireless networking service with $130 billion of revenue in 2018. And it's a Fortune 20 company. And we recently launched the first commercial 5G service in the world. Also, we own several other brands like AOL, Yahoo, Verizon Media, and Visible. Hope we are all using Verizon phones. OK. At Verizon, we are in the middle of a digital transformation and app modernization strategy. So to give a sense of the scale at which we operate, we have around 2,000 plus applications, ranging from brownfield applications to the greenfield applications, monoliths to the modern 5G apps. We have 80,000 plus workloads, 10,000 plus developers and the engineers, and 300K plus deployments over the past 90 days, and 1,000 plus commits every day. We do this all to support our 100 million plus customers and the connected devices. The scale is huge. So to modernize this landscape of applications, we put together a grand strategy of app modernization. The first core component of this strategy is setting up a centralized enterprise architecture organization and building a North Star reference architecture. So the goal of the North Star architecture is standardize the platforms and the tools and help the organization to build the reusable components. The second core component of the strategy is implementing the North Star architecture itself so that all the applications can be modernized. The Kubernetes is core key component of this architecture. So we have the several various different needs. For that, we have the Kubernetes platforms on-prem, because every day we deal with customer-sensitive data. So we cannot move some of the apps to the cloud. So we have the Kubernetes clusters on-prem. We have it on AWS. We have it on Oracle Cloud. And we are planning to build hundreds of clusters on the edge locations. So even the platform point of view, the scale is huge. The third core component of this strategy is our vision, our lofty goal is to containerize the 50% of these applications by the end of 2020. This can be possible only by improving the developer experience, right? But this is where we started getting into the problems and the challenges. Security posture at Verizon is pretty strict. The first problem, we cannot run the Docker runtime or the Docker daemon on a developer desktop or a laptop. This is the first speed breaker. Because we have a strong virtualization policies on the desktop nodes. We need to solve this problem. The second one, we heavily invested in the image scanning. That means that before we push an image to the Kubernetes cluster, it has to be scanned. If there are any vulnerabilities, we cannot promote them to the next production and next environment. So bringing the developer community to use the latest and the greatest images and approved images, and integrating the scanning with the pipeline so that the developers can get the visibility of these vulnerabilities in a real time and they can fix it. This is another major challenge that we faced. The third one, as I mentioned, we have several cluster endpoints. One is on the cloud, one is on the on-prem, one is on the edge. We believe that a developer writes a line of code that is more impactful if it satisfies the business need than spending a lot of time on building the pipelines and connecting to the clouds. So we need to solve that challenge. So there are several challenges that we wanted to solve. So our first answer, how can we enable the developers actually develop and innovate with the security posture, right? So our answer for this one, this is the first solution that we iterated last year. Okay, you cannot run the Docker locally. So build the EC2 image, set up the Docker environment, build and develop and build the images, and scan it, push it. So that means we enabled a remote environment to the developers on the cloud. But you can imagine, as a developer, this is not an ideal solution. So again, we ran into the several problems. The first one is running the Docker in a Docker. It gave us a poor performance. The second one, if you're running a developer environments on the cloud, you have a public cloud restrictions. Again, that started hindering the developer productivity. So also, it started adding the cost. And we know that this is not a user-friendly. So at the end, it started impacting the developer productivity. So that means 1.0 was not a real solution, and it will not help us to achieve our lofty goal. So now, this is the time to redefine the developer tools, redefine the developer workstation, so that we can put the tools, we can tool the workstation, and developers can build the applications without a Docker daemon or the Docker runtime that is running on the laptop. So we need to find a solution for that. So we spend a lot of time putting together what tools can help us to solve these problems, these security problems. So when we identified the entire container workflow, we identified the 6 stages. One is the code, one is the build, and then the developers will test it, and then scan the images, then they will deploy the images, and they will run the images on the Kubernetes clusters. So for the code and build and test, we've identified 3 amazing open source tools. The first one is Kaniko. You can build the images without a Docker daemon. That means that you can run these Kaniko on the Kubernetes clusters and without an unprivileged state. Also, we have almost 30 to 40% applications are Java applications. When you want to modernize, we don't want our developers to spend a lot of time in writing the Docker files. So the Jib helped us to take the entire Java code base without writing a Docker file and create the image and push it to the Kubernetes cluster. The third, the one I like most, is the Scaffold. Scaffold is totally transformed our local Kubernetes developer environments. You can build the images, you can push the images, and you can run these images on the clouds sitting in the IDE. And it has a great integration with the file system, so that as a developer, when I go there and make the change, automatically triggers the pipeline, it builds the image, and deploys it on the cluster. So these three tools helped us a lot for the code and build and test. For the scan and deploy, for some applications, they are not Java, but I need to write the Docker file. How can we make the life simpler so that I can just write the Docker file and put it on the clusters? So GitLab runners helped us. We are going to showcase a demo today of all these three use cases. The next one is the Harbor is our image registry. It has a great integration with the security scanners. As a developer, when I build the code and create an image, drop it on the Harbor, you can see that, hey, these are all the vulnerabilities. You can just go and fix it. OK, this is good. Then promote it to the production. Finally, for the run part, we identified the two tools. One is Octant and QE. Octant easily provides the visualization of the different clusters and provide the logs of the pods and the containers in real time. And also, QE is an amazing CLI visualization. Today, we can see that how best we can use it. With this further ado, I will hand it over to Brian to showcase us these three use cases and give a demo how we use these tools at the enterprise level.
OK, thanks, Sharat. So I'm going to go ahead and pull up some pre-recorded videos I have here so you don't have to worry about issues on the day of. So I apologize for the brevity on some of these. Honestly, most of these tools could probably be their own individual talks. But what I want to try to illustrate is how we're piecing them together and using them to kind of get around some of the issues that we're facing with things like not having a Docker daemon, running Docker and Docker, the types of issues that Sharat illustrated earlier. So I'm going to follow kind of the same way they were presented in the slide. I'm going to talk about the developer tools first. So this will encompass Jib, Kaniko, and Scaffold. Then I'll talk a little bit about how we're kind of enhancing our automation by going towards GitLab runners. I'll point out some of the features in Harbor that we like to kind of help with some of the vulnerability and image management issues we face. And then finally, I'll wrap up with the two visual tools. OK, so let's go ahead and get this started. So the first thing we're going to look at is Jib. And as Sharat mentioned, we have a huge Java footprint in Verizon. And Jib is a pretty excellent option if your developers aren't super well versed in doing container development. So what I've got here in this example is basically the getting started app from Spring Boot's documentation. Just pulled it off GitHub. It's a simple REST service that returns that message there. And I've also put together a manifest real quick. So once I have a built image, I can go ahead and deploy this to a cluster and just kind of see it visually in the browser. And then if you're kind of looking at the left side, the hierarchy there of the project, you'll notice there's actually no Docker file present, because as I mentioned, Jib does not actually require one. The nice thing here is everything in Jib, since I'm using Maven in this example, is actually just a Maven build plugin, which you'll see right here, Jib Maven plugin, version 1.7. And all the configuration for kind of how the Docker file is built is done within here. So you'll see some things that actually kind of translate one for one from an actual Docker file. You'll see a front statement for the runtime that I'm going to base my image on. The to is the destination. So in this case, I'm just using my private Docker registry. And you can attach as many tags as you like. I'm doing one for the Maven artifact version and just tagging latest as well. I've set my entry point here in the container. So the main class is hello.application, exposing port 8080 because that's what it's going to run on. And then I could just throw whatever labels in there I think are relevant. So I've put maintainer on there. So with any luck, all I'll have to do is kind of do a Maven clean install. And what I'm showing here, there's nothing in my registry at the moment. It's completely blank. No tags have been pushed. And then I'm going to go ahead and jump back to the IDE here and run that Maven install. And what's going to happen is you'll see basically a big dump of console output, pretty typical Maven. And then at the end here, you'll see Jib in action. And it's basically analyzing the dependencies and splitting them into layers so that if I do a subsequent build, it'll go a little bit faster and only rebuild what's necessary. So kind of flashed there quickly, but essentially you saw the two tags get pushed to the registry. So Jib successfully built it and pushed it. So with the manifest prior to this, I just did a kubectl apply just to make sure that it was running. You can see it on the cluster. So I'm going to go ahead and tear that down. And then the next tool I want to show is Scaffold. So Scaffold is basically letting us kind of orchestrate pipelines within the developer's environment itself. So you do have the ability to build images through Scaffold as well, but since I've done that through Maven, I'm kind of skipping that for now, and I'm just doing a deployment here. So what you'll see is it's actually built a skeleton for me if you run Scaffold init with the CLI tool. And it's discovered that I have a manifest in there, and it's basically created this little template for me. And it's using kubectl to deploy the manifest. So I have a valid kube config already. I've logged into my cluster, and it's using that to figure out how to reference the info it needs. So really, it's just a matter of hitting Scaffold run. You'll see here it basically did the push. If I go and look again, I'll see that my deployment is there, my service is there as part of the manifest. And then if I were to pull up my browser and kind of go to where I'm expecting this to be, refresh, I'll see it's still there and it's still working. So this is pretty cool. One thing that's a little bit annoying is having to jump back and forth between a terminal and the IDE, especially if you're using something like Eclipse or IntelliJ where it has the Maven integrations in there. So you have a few options. Scaffold Dev basically is the watcher that Sharat mentioned, where it's going to look at the file system. Anytime there's a change, it'll create a dirty commit, push an image with that ID, and we'll also temporarily spin up the things until you terminate the process where it will tear down your resources again. But I think that's not too intuitive for how our developers work, at least in Verizon. Typically, people aren't going to want every single little change in the code that they do to be pushed, and then they're going to refresh their browser and check. They'll probably do maybe a handful of changes and then do a reinstall. So I'm just using the Maven @run plugin here. I'm calling Scaffold run as part of my build. And I think that's a little bit more in line with how our developers work. So now they don't really have to leave their IDE in order to see these changes. So I'll just go ahead and update the message here just to show that this is working. Just add KubeCon 2019 there and keep it festive. And then I'll do another Maven clean install. So we'll get the same thing. Jib is going to do its thing. And then at the end there, we'll see real quickly spit out the deployment via Scaffold. So with any luck, if I go back to the browser now, and I refresh this, we should see the changes. And sure enough, there they are. So this is pretty useful for Jib for teams that are largely written in Java already, and you don't want to have to go through the effort of having to retrain people into how to do container development. It also additionally doesn't need a Docker daemon, so that's pretty valuable. But let's say you don't have a Java app, for instance. Or maybe you have Docker files that you've already invested in and you would like to just build those, but you don't have a Docker daemon running in your developer's local workstation. So what I want to show here is Kaniko. So this is an option for building, basically offloading the Docker build itself to an external container or Kubernetes cluster. So in my demo here, I've just got a really simple Node app. It's basically the same thing, just written in Node. It's an Express app returning a message exposed on port 8080, as you can see here. And then I've also got a Docker file to go with this based on Node, just does the npm install, copies dependencies in, exposes the port, and sets the entry point to the service itself. So let's take a look at my new Scaffold config. So this time we see I actually have a build key in there defining that I want to build a Docker image. And in Scaffold, it has native integration with Kaniko, so it's one of the options for building Docker images. So you'll see in there, I've got a tag policy set, and I'm basically just defining that I want to push the latest tag just for the sake of this demo. I've also got Kaniko defined, and since my Docker file is locally, I've set it to the local directory for the build context. Additionally, since I'm pushing to a private registry in this example, I have a secret that I already placed prior to the demo into my cluster, and it's basically just a Docker config file with the credentials that it needs to access it, and it's in its own dedicated namespace. And then at the very bottom there, we still see the same manifest. I didn't change anything about it. It's exactly the same. So what we're going to do here, let me take a look at the video. OK. So I'm going to go ahead and run Scaffold run on this now. And what we'll see is now Kaniko output as it's offloading to my cluster and building it. So it kind of is a little bit slow, admittedly. I kind of fast forward the video for the demo. But basically what it's doing here is unpacking the root file system and the pod that it spun up, making the changes as requested by the Docker file, then basically recompiling it and shipping the Docker image to my registry with the tag that I defined. So it looks like it succeeded here. If I go ahead and pull up the browser again, you'll see for my tag there on latest, that's the old one that I did 5 minutes ago in this recording. If I refresh it, looks like it succeeded. It was updated. And because it's updated and it redeployed, if I go ahead and refresh the tab here with the service, now we'll actually see the Express apps output instead. So Kaniko, great option if you're not running Java, for instance. So next, let's jump ahead out of the developer space a little bit more into the automation and kind of talk about how we're using GitLab runners in Verizon. So our first foray into CI/CD with Kubernetes, we were using basically co-located Jenkins slaves. And we were using basically a Docker and Docker model where developers could provide their image with the dependencies they need to do their builds and deployments, run that on the slave. Obviously, there's issues with Docker and Docker from a security and performance standpoint. So we kind of wanted to get away from that. So the user experience wasn't super great. So we were looking at GitLab runners in Verizon since we're using GitLab as our source control. And what I want to show here is we have a runner which was actually deployed as via Helm to a cluster here. And this runner is essentially just like an agent listening to pipeline build requests from the GitLab server itself. So I'm taking that same Java project from before, and I'm basically just going to build a Docker file from this as part of a pipeline. So this time I'm using a Docker file. You'll see why in a second instead of Jib. Jib is an option as well, and it's probably a better choice, but I think I kind of show some stuff off here instead. So everything in GitLab runners is controlled via this GitLab YAML file that's in the root of the directory. I believe Travis uses something similar, if you're familiar with that. And I guess it could be a little overwhelming if you're not familiar with what a GitLab CI YAML file looks like. So I'll kind of just highlight the main things here to save some time. So let me zoom in so it's a little bit easier to read. So what we've got here are basically two jobs. A lot of the other stuff in here is just caching optimizations to make builds go faster. So sort of just try to ignore those for now. The main things to look out for is that you have the job name, and then within a job you have a stage for the Maven when it's built. The image is basically the runtime that we're going to run this job in. And then the list of scripts is basically commands to execute within that Docker container. So in this case, I'm using a Maven environment. The GitLab runner will automatically fetch the repo and attach it to that container so that you can access anything in your source code. So what I'm doing there is just basically doing a Maven clean install to build the jar file. And then our good friend Kaniko makes a return in GitLab runners. There is support for this, and this is GitLab's recommendation for doing Docker builds within GitLab runners to avoid Docker and Docker situation. So here we have Kaniko. It's in the stage deploy. I'm using the Kaniko image. I am overriding the entry point here because by default, it will just try to run the executor, and I want to wait a second. So instead, what I'm doing is, again, I'm echoing permissions, the Docker config file I need to push my image, and then I'm calling the executor. And you'll see a couple variables defined in here. These are actually stored and masked within GitLab's project settings itself, so they're not stored within the code. The only people who actually have access to that are admins of the project. So I'll go ahead and run this pipeline just to kind of show the visual output you'll see and what developers can kind of expect when they use a GitLab runner. So here I've run it. I've got the Maven and the Kaniko jobs that I expected. And then I have that commit there, which I'm going to be using as the image tag for the finally built image. If I click into one of these jobs, I'm going to get the console output. Again, it's just going to be a big dump of Maven output, pulling dependencies and things like that. So I'll just kind of back out of here. And now that that's done, let's take a look at kind of like what's going on in the background while this Kaniko job is running. So if I pull the cluster back up, we'll see that there's this extra pod here. And what it's doing is for each job that's in your pipeline, it spins up a separate pod to manage that. So it's going to scale in and out as per demand. So here in the output, we can see it's basically fetched my repository. It's running all the commands that I've defined in Kaniko. So it's echoing the Docker config. And then sure enough, it completed. If I refresh here, we'll see that I've got my new tag and it built. So this is obviously the next step would then be deploying a manifest or something. But for the sake of the demo, I'll just cut this part off here. But this is just a great option if you are kind of in the same boat as we are, where you're currently running Docker and Docker, you want to get out of that. I suggest either looking at GitLab runners or figuring out how Kaniko can kind of fit into your existing pipelines. And now we'll look at Harbor. So Harbor is our open source registry option. There's a lot of features in Harbor and a lot of value to get out of it, but I'm going to kind of point out the main things that we care about in Verizon. So the first being the RBAC integration. In this example, I'm using LDAP, but it also has OIDC as an auth mechanism for users. If you're using something like Dex, you may be interested in this. It also has its own internal Postgres database if you want to do some kind of integration of your own with that. But more importantly, I think, is this feature here that I'm demoing in the configuration of one of the projects. And you'll see there's a checkbox here to prevent vulnerable images from running. So what's going on is we've chosen to include Claire in our installation of Harbor here. And Claire is an open source vulnerability scanning tool. And it is integrated in Harbor, so you can actually select images and scan them all within the GUI. And you can also prevent images from being run that don't meet certain thresholds. So for instance here, I don't want anything that's detected with high vulnerabilities to be allowed. So I've pushed just the Debian Stretch Slim image in here so you can kind of see what that looks like visually. You'll see there's kind of a little color graph here depicting the vulnerabilities that were scanned. There's some other features here too. So if you're using a notary, which is included as well, it will show a check or an X if it's been signed or not. And then information about the last push and pull time, little copy command if you need that for whatever reason. And if you look in here, you'll actually get a deeper dive into the vulnerabilities. So you'll see there's a couple severities here that are low. In our case, this would be acceptable since we set it to high. But you can also kind of click down here, see what they are specifically. And this is great for the developers so they can actually kind of have the scan integrated into the registry that they're pushing to, see what the issues are that they need to resolve. And we like to couple this feature with another feature, which is basically replications. So with Harbor, you can push from Harbor to another registry of your choosing, or pull from an outside registry and stage it in Harbor. So I'm going to quickly kind of skip ahead here, because I think it's mostly just me setting up a replication here. But in the example, what I'm doing is I'm going to replicate, let's say, Mongo from Docker Hub. I'm just going to take the Mongo 3.0 images, pull them into Harbor. And you can kind of think of this as a quarantine, which is how we plan to use it. So generally speaking, we don't want people pulling images straight from Docker Hub, from GCR, whatever external repo, and running them in the cluster. So instead, what we'd like to do is basically create a quarantine, have people look at the images that get pulled in, look at the vulnerabilities, and if they're acceptable, they can just get promoted into, say, like a production grade registry, or the developers can iterate on it, patch it, and then push it to that registry. So we'll see here, I triggered a replication. These can be scheduled on a cron to happen regularly, but I just did a manual scan. And with any luck, I should see here that the Mongo 3.0 images, the tags were pulled into this registry. So there's library Mongo, 8 tags. Prior to this, I scanned 3.2 just to test it. It was working, so let's say I want to scan 3.6 and see if there's vulnerabilities. I'll go ahead and click there, click scan, and it'll queue it up with Claire. You'll see it does the scanning, and then again, it gives me that visual layout. So those are the main things I wanted to show with Harbor. Again, it has a lot of other features. It also functions as a chart museum if you guys are looking for a location to store Helm charts and share them. I mentioned the notary as well. So definitely take a deeper look at this option if you are looking for a more feature-rich registry option. And then finally, I just want to quickly wrap up on these tools because I know time is kind of running out. So once our developers have something running, what's the best way for them to kind of start troubleshooting it and make their life a little easier? So if you guys are familiar with the Kubernetes dashboard, Octant, which is the first one I'm demoing here, looks pretty similar. It's a little bit different, though, because it runs on the client itself, again, driven by the kubeconfig. So on the top right there, you can see if I have multiple clusters defined in my context, I can flip between them. I can flip between the namespaces that I have permission to. And then what it's doing is basically taking the same output I would get from kubectl commands, putting them in tables, putting them in charts and visualizations, making clickable links to kind of browse the various chains of dependencies there. And it makes it easier for developers to basically understand what's going on with their deployments. So if another nice little feature, I'm going to jump ahead here just a tiny bit. You can see the actual raw resource output if that's what you prefer to do or you want to share it. But if you have, say, a pod specifically, one other option here, when I scroll back up, you have the ability to kind of tail the logs in the browser as well. So Kui has some overlapping functionality, which I'll get into real quick. So for those of us that prefer working in kubectl and do like the command line experience, Kui is what I would probably describe as kind of like an enhanced kubectl shell. So as you can see here, just doing a get pod, there's a little bit more visual flair showing the status and whatnot. But it's an Electron app, and it provides clickable links here. And again, it's just another way to kind of more easily view my deployments and understand how they're doing. If I want to click into the containers of a deployment and kind of look at the logs, that's also an option here as well. One little caveat with Coope is that right now I believe it only runs on Linux distributions and Mac OS. There is no Windows option, which may not be an issue for a lot of you anyway. So go ahead and check that out. And that pretty much wraps it up for the tools that I wanted to demo. I want to leave a little time for Q&A, but first I'll invite Sharat to kind of come back and close out the presentation with any final remarks. So let me go ahead and pull that back up real quick. That full screen. There you go.
So in a nutshell, there are like several open source tools that are helping us to improve the developer productivity. Either you can write the code and build the images, or scan it, or deploy it. So there is an entire set of the tool set that is helping us, our developers, to improve the productivity so that we can achieve our app modernization goals. So at the end, we don't want to focus more time on the infrastructure side. Our developers, we want them to focus on writing the code that really satisfies the business needs, right? So there are like so many new tools are popping up every day. Probably these are the few of them. Maybe by the next KubeCon, you might see a few more. But all these tools are helping us on a day-to-day developer activities. As a part of Verizon is a member of CNCF, and a part of this one will embrace all the open source tools, and we support the open source community. With this, thank you very much, and hope you enjoyed this session and identified a few tools that can help us. Tomorrow you can go and try at your work locations, and have a great rest of KubeCon.
So we do have time for a couple of questions. Here we go.
Great presentation, gentlemen. Scott Fulton from ZDNet. You did a wonderful job of showing how and why Verizon is bypassing the Docker daemon from being run locally. But could you explain kind of, if I didn't catch it the first time, encapsulate, what is it about Verizon policy that prevents you from having the permission to run the Docker daemon locally?
Want me to take it? I can take that. So admittedly, it's probably somewhat antiquated, and it is actually something we're actively discussing with our security teams to kind of get a better understanding what the problem is. So, I mean, right out of the gate, like a lot of our developers are using Windows laptops. Hyper-V is disabled, and VirtualBox is blocked, so there's really no way for them to even go about using Docker for Windows.
Yeah, at the end, it boils down to the virtualization policies. And once you provide the access to the virtualization, you can run whatever you want, and you can take the data from the laptop.
So that's their stance. They've invested a lot of time in like making sure that the processes running on our developer workstations are secure, and their fear is that containers will kind of obscure that for them.
Sure. So, whoa. You mentioned that the need for understanding Kubernetes for developers is going down, and you mentioned all these technologies, but you haven't mentioned how much training right now your developers need with Kubernetes.
Correct.
Could you give just a brief synopsis of like what recommendations you have for that type of training?
Yeah, I think you hit the right point. This is very important. We can't transform it without the developers understanding the Docker and Kubernetes. The training is very important. It doesn't mean that, hey, I don't know anything about the Kubernetes, but I can build the Kubernetes applications. So that is part of your strategy, the training and upskilling your employees, and partnering with CNCF Foundation, getting the Linux Foundation, getting the courses, and making them available. That is one part of our strategy. And the second one is we are providing the vouchers to our developers, say, become a Kubernetes certified developer and administrator. So there are like several phases and several layers of our training is going on across the organization.
Yeah, in addition to that, I would add having kind of an open community where people can ask questions. So we can't name certain products, but we have certain forums and different tools for people to submit tickets, questions. The rest of the community can come in and help answer, and kind of take some of the workload off of our team to go and upskill everybody. And we've also developed our own internal training plans.
And I know there are other questions. Unfortunately, we need to let the other presenters who are coming in next present, but these guys will be around if you want to ask them some questions just off stage. And please don't forget to rate the presentation on the website. Thank you guys very much.
Thank you.
Thank you all.